O conic sections. Sections of a cone. Let L be a fixed vertical line and M be another line intersecting it at a fixed point V and inclined to it at an angle alpha. Suppose we rotate the line M around the line L in such a way that the angle alpha remains constant. Then the surface generated is a double napped right circular hollow cone, hereinafter referred as cone and extending indefinitely in both directions. The point V is called the vertex. The line as the L is the axis of the cone. The rotating line M is called a generator of the cone. The vertex separates the cone into two parts called naps. If we take the intersection of a plane with a cone, the section so obtained is called a conic section. Thus, conic sections are the curves obtained by intersecting a right circular cone by a plane. We obtain different kinds of conic sections depending on the positions of the intersecting plane with respect to the cone and the angle made by it with the vertical axis of the cone. Let beta be the angle made by the intersecting plane with the vertical axis of the cone. The intersection of the plane with the cone can take place either at the vertex of the cone or at any other part of the cone nap, either below or above the vertex. When the plane crosses the nap other than the vertex of the cone, we have the following situations. When beta equal to 90 degree, the section is a circle. When alpha less than beta less than 90 degree, the section is an ellipse. When beta equal to alpha, the section is a parabola. In each of the above three situations, the plane crosses the entirely across one nap of the cone. When 0 less than equal to beta less than alpha, the plane crosses through both the naps and the curves of the intersection is a hyperbola. Indeed, these curves are important tools for present-day exploration of outer space and also for research into the behavior of atomic particles. We take conic sections as plane curves. For this purpose, it is convenient to use equivalent definitions that refer only to the plane in which the curve lies and refer to special points and lines in this plane called foci and directrix. According to this approach, parabola, ellipse and hyperbola are defined in terms of a fixed point called focus and fixed line called directrix in the plane. If S is the focus and L is the directrix, then the set of all points in the plane whose distance from S bears a constant ratio E called eccentricity to their distance from L is a conic section. As special case of ellipse, we obtain circle for which E equal to 0 and hence we study it differently. Thank you.